Okay, this section is on the indefinite integral, which is actually pretty easy since we've already done 4.9. There's really no difference other than the way we've written it. So the indefinite integral is basically saying find the antiderivative. So if I'm looking at this guy, the antiderivative of 3x squared, again, I'm going to add 1 to the power and divide by it. So I get 3x cubed over 3 plus 2, again, x to the 1, so it becomes x squared over 2 plus 5x. And then this one I'm going to have to remember to add plus c because this is an indefinite integral, not a definite integral, so we're going to have our constant in this case. So there's our first example. Example 2. So find the integral of x plus 3 times 2x minus 1. Again, I can't just do it piece by piece. You might be tempted to say, well, that's equal to x squared over 2 plus 3x times 2x squared over 2 minus x. That is not okay. We cannot have things multiplied by each other when we're doing it. We can do each part individually if it's added or subtracted. If we have multiplication and division in there, we got another thing we got to do. So first things first, we're going to multiply this through. So x times 2x gets me 2x squared. X times negative 1 gets me negative x. 3 times 2x gives me plus 6x minus 3 dx. So I get the antiderivative of 2x squared plus 5x minus 3 dx. So I get 2x cubed over 3 plus 5x squared over 2 minus 3x plus c. And that's all there is to it. Example 3, this is very similar to an example that we did in the last section, but this time we don't have to plug anything in. So the first thing, again, you can't just do each part individually. We've got that big division in there. So what I've got to do is split it up, and I'm going to split it up as s squared over s minus 3 root s over s plus 7 over s ds. So s squared over s is just plain old s. This is s to the 1/2 minus s to the 1 gets me minus 3s to the negative 1/2 plus, and again, I'm going to leave the plain old s on the bottom alone. So what's the antiderivative of s? It's s squared over 2 minus, now I'm going to add 1 to this exponent, so s to the 1/2 divided by 1/2, so minus 3s to the 1/2 divided by 1/2 plus 7 ln of s plus c. And finally, let's just simplify this last term down. S squared over 2 minus 6 square root of s plus 7 ln of s plus c. Example 4. So again, basically the hard part is trying to do about these sometimes is you try to do things that you're not allowed to do. So this one you might look at it and you might say, okay, this is 5x squared over 2 times 2x to the 4th over 4. Or sorry, not the integral sign would be gone, plus c, but that is not allowed. Again, we got to multiply it through first, so I get 10x to the 4th dx, and now I can do it. 10x to the 5th over 5 plus c, which is equal to 2x to the 5th plus c. So just make sure you have no multiplication or division in there. That's not allowed. This guy, cosecant squared u minus cosecant u cotan u. So if we look at this, we can split it up as integral of cosecant squared u minus, well, or actually let's do plus the negative cosecant u cotan of u du. So what's the antiderivative of cosecant squared of u? Remember, derivative of cotangent is negative cosecant squared. So this will be negative cotangent of u. So if we look down in our chart here, again, negative cosecant squared goes to cotangent. So cosecant squared would go to negative cotangent. And similarly, negative cosecant cotan goes to cosecant x. So we're going to have plus cosecant u plus c. And that's our answer. And that's all for this section. So there's really nothing new in this. It's everything we did already in 4.9. The only thing that's different is how we wrote the questions. That's really the only difference.